Hey everybody, welcome to Linux Hint YouTube channel. Today we have a long course for you in which basically we are going to teach you how to code um, in a general perspective. So the idea is that you can code in any programming language that you almost want to if you know the basics of coding. And the purpose of our course is to teach you that. So the idea is that you could be working with Java, you could be working with Python, you could be working with C, C++, C Sharp, JavaScript. The basics are essentially the same. The only thing that's going to be different is going to be the code, the syntax, right? So if you understand the logic of coding, if you understand the reason behind every line, you could learn the syntax of any programming language and then you can code in it. So the purpose of this video is to make you familiar with those concepts, and in order to make you familiar with those concepts, obviously we need some programming language or platform where we can teach you those basic concepts. And that's why we have chosen this C++, which is basic, which is very easy to use, and we're going to teach you some basic programming's fundamental concepts which are essential in coding. So when you would learn all of them, it is very much likely that you would be familiar with other programming languages as well. The only thing that you need to learn would be their syntax. Okay, so you can code in pretty much every language if you would learn these 20 topics that we have. So let's start without further ado. The first topic is introduction to coding. So the idea is that the computer that you and I communicate with doesn't understand our language. So for example, if you would have to say to your computer in English, hello, can you open up a folder for me? Then this computer won't understand you, right? So in order to make this computer understand what there is a phenomena that is happening in the background. So let's say that you're writing some code in programming language, you're giving instruction to the computer, and let's say that I write here a general statement print and I say hello world. Okay, so this is just a general statement. It could be of any programming language. You can understand that because you have seen it, but computer won't understand it really. The only language that computer understand is the binary language, which is consists of zeros and ones only. Okay, so this is the combination that computer understands. So the idea is that in order to convert these lines that you would write for C++ or any other programming language, we usually have a compiler. Okay, so you would find many compilers of C++ and C online on your browser. When you'll browse it on the internet, you have C++ Turbo. There is another famous one for C that I forgot. So you can pretty much search on internet and you can download those IDEs. IDE is basically an integrated development environment, okay, in which you can code. In Linux, however, for C you have GCC library, and for C++ you have the G++ library. All right. Okay, so now take a look here. So this is print hello world. This is a syntax of a programming language, and if you take a look here, this is a binary language, okay, which is a language of a computer. So the idea is that your compiler would basically convert this one here. If you take a look, so it would convert this print hello world, this syntax of a programming language, into the language of the computer or binaries, right? So in order to convert this statement to the computer's language, you usually need compiler or interpreter. So with the help of the compiler, this language would be converted into computer's language. Computer would understand the command in his language or its language, and then it would execute that command. So for example, we have here hello world. So what's going to happen that compiler would translate that into binary zeros and ones, and zeros and ones computer understands really well. So these instructions are now being given to computer, and computer would execute and it would print hello world ultimately. Hope you have got the point. So you can also set up the IDE. In Linux Ubuntu, it is very simple. All you have to do is that you have to press Ctrl Alt T and open up your terminal, and you have to check if your G++ version is installed. So if you write this command G++ and space and then double hyphen and then version, if you write that, then you'll get the version of G++, which is Ubuntu 7.5.0 here, which means that we have G++ set up already. So in case you don't have G++ version installed and this gives some kind of error, in that case you can write here sudo apt install, and then you could write here build essential. All right, so that will basically install G++ version for C++, and if for C GCC version, if it is not installed, it would install that as well. Okay, hope you have got the point. Okay, so now let's talk about why you should learn C++. So the idea is that C++ is known to be a very powerful language. C++, it allows you to have a lot of control as to how to use computer resources. You can use those resources in the right hand. You can control its speed and the ability to cheaply use those resources. These are kind of the things that actually make C++ important, really important. And usually when you would have seen that people who are learning coding, they're beginners, they're starting, they actually prefer C or C++ a lot. Now, I'm not saying that people don't use Java or Python or other programming languages to start to learn the code, but it is a very popular language that is being used to learn coding. Okay, so it is fairly simple, very understandable, and it's scalable. It has a friendly gesture for beginners. Okay, and there are multiple future career opportunities in C++ as well. So that's why C++ is really important, and that's why we are using C++ to teach you to code, right? Because if you're a beginner and if you don't know how to code, this video would change your life, because in this video we are going to break the fundamental concepts of programming, using which you can easily learn the basic concepts of programming, and then you can apply it on advanced level. You could basically learn any syntax of any programming language, and then you can apply the same concepts that you would learn from this video. Okay, because the base of the programming, the foundation of coding is almost the same, right? All right, so now let's move on to our third topic, which is C++ first program that we are going to write, and that program is going to print out hello world. So what you're gonna do is that first of all, you're gonna go to your terminal and you're gonna go to the folder where you want to create that file, or that CPP file in which you would write C++ code. So I want to create that on my desktop. So for that, I would just go right here and I would write here touch hello.cpp. So I hit enter. If I do ls here, you can see that hello.cpp, this is a file that have been created on my desktop. So now what I'm gonna do is that I'm gonna open it. I could open it in Nano Editor as well, or I could open it in gedit as well. So let me just gedit hello.cpp. I hit enter. Now this file is, it has been opened up. So first of all, we're gonna add a header file here. So that would be like iostream, let's say. And then what we're going to do is that we're going to have a body of the main block, which will be executed first. So no matter what happens, if you're even studying functions, the idea is that whatever is inside the main block, it is going to be executed. So if you have written other functions that we'll talk about later in the program, they are not being executed. They would only be executed if you would call them inside the main block. So you can say that this main block is the main place where execution would happen. So do not forget that. So whatever you would write in here, that would be executed for sure. So we want to write here a cout statement, which means that we want to print here hello world. So what we do, we just write here hello world, and then we just simply write here semicolon, and then we can write here return 0, which is nothing but it tells the compiler that now here the main function is ending, right? So press Ctrl S or save it, and go back to your terminal. Let's try to run that code now. So in order to run that code, you have to write here G++. We have already checked the version, we already have it. And then you're going to write here the code name, which is essentially hello.cpp. So this is our code file in which we have written our code. So now when you would hit enter, it would compile it. If there would have been any errors, it would have shown all those errors here in this command line. So right now our code, our program, it does not have any errors. So that's why it has not shown any errors here or any warning sign. So now it means that we are good. So if we take a look at our desktop now, we have an extra executable file, which is a.out. It is a binary file. So what we can do is that we can run this binary file to get the output result. So we'd write here / and then a.out, would hit enter, and you can see here that we have hello world right here. So you can say that why it is not appearing in a separate line. So in order to separate this thing from this line, what you can do is that you can open up your hello.cpp, and in here you can write here /n. So what that /n would do is that it would take it to the next line. So if we save it, let's get out of here, and if we try to run our program again, we have compiled it, there are no errors. Let's run the binary file, and you can see that we have hello world right here with the separation. Okay, so /n takes the cursor to the next line. Hope you've got the point. Alright, so now let's move on to our next topic, which is C++ data types. So the idea is that a data type is nothing but a container of a specific type. So a variable is actually a container, and the data type helps the variable to store a specific kind of data. So for example, if a variable is of integer data type, then it means that the only integer variables can be stored in that variable. So in the previous topic, we have discussed this cout hello world. So the idea is that this is basically a syntax. This is a print function, a simple print function, which is doing nothing but printing hello world. And in the similar way, in other programming languages, there would be print functions, but they would be of a different syntax. So for example, in Java, you have system.out.print. In C, you have printf. In Python, you have print, and so on and so forth. So the difference is just the syntax, this cout thing. The logic behind this print function would always remain the same. Hope you've got the point. So now if we talk about the data types, so the idea is that there are multiple data types in C. First one is integer, okay? And usually use it like int, right? So the idea is that it is used for integer data types, and integers typically requires 4 bytes of memory space, and it ranges from let me just write here the number. Ranges from, first of all, let me write here 4 bytes of memory, and it ranges from 2147. So this is the range of the integer. The second data type that C++ offers is a character data type. Okay, so the character data type, the idea is that it is used for storing characters and the keyword that is being used for it is char. So the idea is that, for example, if you have hello, then H is one character, E is one character, similarly L is one character, and the second L is also another character, and then we have O, which is also a character. So the idea is that character data type stores the the data character by character. And if we talk about the character, it requires usually 1 byte of memory, and the range of it is from minus 128 to plus 127. All right, or from 0 to 255. Okay, and also this one is minus or negative, right? Hope you've got the point. So the next data type, the famous one, is Boolean. So the idea is that Boolean data type is used for storing Boolean or logical values. A Boolean variable can store either true or false. These are the two possibilities. Other than that, you can store nothing in the Boolean variable, only true or false. So the key word for that is BOOL. This is the keyword using which your compiler would recognize it. So the next thing is a floating point. So you write here floating point, and floating point it has a variable representation or data type representation, excuse me, which is float, like this, FLOAT. So floating point data type is used for storing single Procyon floating point values or decimal values up to 1 point or 2 point, right? So keyword used for floating point data is float, that we have discussed, and the float variables, they are typically the same as the integer, slightly different. They typically require the same amount of memory, which is 4 bytes, like this. Okay, and the example of that would be 12.1. So this is a float number, okay, and 12 would be an integer number. 12.1 is the floating number. And in the similar way, we have another data type, which is double. So double data type, let me just write here. So it is usually represented by this double, right? And it typically requires 8 byte of the memory space. Okay, 8 bytes, and the example of that would be 128 or 12.3431. So this is basically a double data type. All right, so these are very popular 5 data types. There are other data types as well, such as void, wide character, and double floating point as well. So these are the main ones that we have discussed here. So once you understand these main ones, there would not be any difficulty to understand the other ones as well. So hope you've got the point. Let's talk about C++ comments. So comments are something like, you can say, meaningless for a machine or computer or your compiler, and they are meaningful for humans. So let's say that you're a programmer and you write code. So sometime you would use some kind of logic that would be difficult to understand for some other human. Okay, so for that, what you can do is that you can add in your language, in English, let's say, you can add different comments that would basically explain the structure of the code, that how that code works, and etc. So let's say that we have a C++ program right here. So what we can do is that if I want to comment it, I can comment this thing into 2 ways, okay, 2 fundamental ways. So one way is that I just simply write here /, and what it would do, that this line would become a comment. Okay, this means that it has no impact on compiler, whenever compiler would be running it, it would not consider it. So what if I want to comment down multiple lines? So in that case, what you can do is that you can have a slash here, you can put a static here, and wherever you want to end the comment, what you can do is that you can write here is static and then slash. So now these two lines have been commented, and you can basically comment in the same way hundreds of lines if you want to. Alright, so you have that option. So the comments are basically nothing but a, you can say that humans, the programmers, use that to explain their code to the other humans. Okay, so machine won't understand comments. So let's say that if I want to tell someone that what this thing is all about, so I would just write here something like that, and I would write here, this is the hello world code, which would print out hello world. Okay, so this is a comment. All right, it has no impact, and the compiler won't actually get it. It would basically neglect it. All right, so what we can do is that we can save it and test it. If I go back to my terminal and if I try to run my program, it has not given us any errors, which mean that the program does not have any errors, right? So program is okay. So now what I would do, that I would run the binary file ./a.out, and you can see that it has printed out hello world, and this is the hello world code, which would print out hello world is nowhere to be found. Okay, because this is a comment and the compiler would simply neglect it. So let's say that if I remove these slashes, obviously this time it's gonna give an error. Okay, you can see that it doesn't recognize this line. So for that, in order to tell the compiler that this is a comment, we just basically run it as a comment. We run our program, we have no errors, we run our program, the binary file, and we'll get the result. Hope you've got the point. So let's move on to our next topic, which is C++ variables. So the idea is that a variable provides us the named storage that our programs can manipulate. So each variable in C++ has a specific type which determines the size and layout of the variable's memory. The range of the values that can be stored within the memory, and the set of operations that can be applied to the variable. The name of a variable can be composed of letters, digits, and the underscore characters. Okay, so you can name it like anything. That must be the combination of these three things: numbers, names, and underscore. The upper and the lower case letters are distinct because C++ is case sensitive. So there are several types. Most famous types are integer, float, double, and obviously the character type. So what we can do is that we can go to our program right here, and what we can do is that we can create a variable. So in order to create a variable, what is the format? Is that first of all you write here the data type, and then you write here the variable name, and it could be anything. Okay, like this. All right, so what we're gonna do is that now we're gonna write here integer, and let's say let's call this variable a, and let's say I create another variable of float type, let's call it b, and let's say I create another variable of boolean type, which means that it's gonna have only two inputs, true or false, let's call it c. So this is how you basically create a variable in C++. Let me show you how to use it. So let's say that if I want to create another b variable, and let's say that if I assign them a value each, so let's say that if a is equal to 8, and let's say that b is equal to 9, and let's say we have another variable called as c, and we do something like c equals a plus b. And that's the way you can use variables. So what is going to happen, that they are basically storing 8 into a, 9 into b, and then we basically when we do a plus b, which means 8 plus 9, and that would be 17, and 17 would be stored in c. So right now we have not printed it out yet, so it would not give us any results. So in order to, let me run the binary file first so that you can make sure it doesn't give us any output. So in order to get that output, what we have to do, so now what I would do, I would have here C out, and then I would basically print out the C, which is essentially the variable which would contain the value 15, and then I would basically end it. So now if I save it, I go back to my terminal. So now what I would do, I would go back here and I would try to run my program, and you can see that there are no errors. So right now I can run my binary file, and you can see that the result is 17, which is 8 plus 9. If you add 9 to 8, the result would be 17. Hope you've got the point. So the main concept of the variables is that they can store any value. There are string type of variables, there are integer, float, double, and Boolean types of variables as well. Hope you got the point. So now let's discuss C++ operators. So an operator is a symbol that tells the compiler to perform specific mathematical or logical manipulations. So C++ is rich in built-in operators and provide several types of operators. So it provides arithmetic operators, plus, minus, multiplication, division, remainder. It provides relational operators, logical operators, bitwise operators, assignment operators, equals, which are equals obviously, and it also provides miscellaneous operators. So we're not going to jump into all of them. Rather, we are just going to talk about the arithmetic operators, and then we'll also talk about relational operators with just without examples actually, and we're going to talk about arithmetic operators with example, okay, so that you can understand better. So let's say that in the code we have done a addition here, okay. So this is basically this plus here, this is an arithmetic operator which add two operands. Similarly, if I would have minus here, this minus is also an arithmetic operator, and it would basically subtract A from B, or you can say the second operand from the first one. Alright, so it would basically subtract B from A, excuse me. If you do here the multiplication, it would basically multiply both the operands. So these are arithmetic operations. It also has division, multiplication. It also has the increment or decrement. So the increment would be, if I write here C++, it means that it is adding 1 into C, and if I do C minus minus, it means that it is basically subtracting 1 from C. Okay, so this is basically increment and decrement. And if we talk about relational operators, you would see that we'd use these relational operators in if and else statements. So if we do something like this, it means that it checks if the value of two operands are equal or not. So if I write here A and then B, so it would basically check that, and it is a relational operator. So if I do something like that, it would check if A is not equal to B. And if I do something like that, it means that if A is greater than B. So these are the relational operators. And if you want to talk about the logical operators, they are basically AND. It means that you would have two conditions. One would be here on this side, and one would be here on this side. So one would be on the left side, and other one would be on the right side. Two if conditions, and if both of them are true, then only then it would let you execute the statement. So it would be true if both of them are true, and it would be false if one of them is false or both of them is false. We'll take a look in the if statement block. And also we have bitwise operators, which are like Boolean, and also we have other sorts of operators, but these were the most important ones that we have discussed: relational, logical, and arithmetic. So remember them. Okay, so now let's talk about the next topic, which is C++ strings. So C++ provides following two types of string representations that I'm going to talk about. One is the C style character string, and the other is the string class type introduced with standard C++. So first, if we talk about the C style character string, then the C style character string originated within C language and continues to be supported within C++. So this string is actually a one-dimensional array of characters which is terminated by a null character. So the declaration that I'm going to show you right now is going to be an array, and it's going to be having different characters. Okay, so what we're going to do is that we're going to show you that how you can actually create a string, right? So let's go ahead. So what we would do, this is, remember, this is the C style character string that we're going to create. So what we're going to do is that we're going to go back to our script or our program, and here we have IOStream. So here I'm going to write here using namespace standard. All right, so once I've done that, now I don't need to write standard with every command that use standard. For example, the cout I'm talking about. So now what I'm going to do is that I'm going to remove all of that, and in here I'm going to write some simple code. So what I would do, I would write here a character array, and I would, let's call it hello, and let's say that it has 6 spaces. Okay, so which means that 6 characters can be put inside. So let's say that I write here H, then I write here E, then I write here L, and then I write here another L, and then I would write here comma, and then I write here O. So hello. All right, so this index would be 0th, it would be 1, it would be 2, it would be 3, and it would be 4. So which means that these are 5 letters, and I can add 1 letter if I want to. All right, but I'm not gonna do that here in literal terms, but I'm gonna do that in terms of a null character. So I'll just write here colon colon, and then I would write here /0, which means that this is a null character. Okay, hope you understand this. So now I'll put a semicolon here to end the line, and now what I'm going to do is that now I have a string basically. So what I can do is that I can print it out using the cout. So what I can do is that I can write here cout, then I can write here double brackets, and then I write here the array name, which becomes a string here, and then I would write here end L. I save it, I go back to my terminal, I try to run my program. You can see that it does not give us any error, and if I run the binary file, you can see that it has printed out hello, which means that now we are printing out a string. Okay, so we're basically having a character array, we're combining all the characters and we're making it into a string, right? So there you go, you can see that we have printed out a string successfully with a C style approach. So there is another approach that I was basically talking about, and that is basically using the standard C++ libraries. Okay, you can take a look on that. That's very simple. So this is your assignment, that we have done C character array for you. You do the standard C++ string yourself. Alright, so now let's talk about C++ if and else statements. Okay, so the idea is that an if statement can be followed by an optional else statement which executes when the Boolean expression is false. So let's say that you have if and else statement. So if, let's say, a is equal to 10, then if that is true, if a is really equals to 10, then it would execute the if block, and if, let's say, a is not equal to 10, then it would execute the else block. So this is the general thing that it could do. So let me show you. So now let's try to write an if statement. So let's say we have an integer here, integer a equals 10, and then let's say we have an if condition here, a equals 10 double equals, which means that we are trying to check if a is double equals to 10 really. So in that case, if that turns out to be true, what I'm gonna do is that I'm gonna write here true, And if it turns out to be false, then what I can do is that I can write here and L, and I can write here else statement. If in case A is not equal to 10, then I got to handle that, right? So what I would do, I would just write here false. Okay, so now I would just write here and L, and that is it. So now if I save it, if I go back here to my terminal, and if I try to run my code, and if I try to write here a dot out, you can see that it tells me true, right? Because it has checked it, a is equal to 10. It is a true statement, so it is basically executing whatever we have inside the if block. And if that would be false, let's say if that would be 9, then obviously it would become false. It would come here, it would check a is not equal to 10, it is 9, so it will leave that. It will not execute the if block, and it would go to the else block and it would execute it rather. Okay, so now this false would be executed and printed out. So if I save it, I go back, I try to run my code, you can see there are no errors. I run my binary file, and you can see that we have the result as false, right? So this is it. And the if block, right now you can see that I don't have brackets around the if block. So this thing is optional and a little bit tricky. So the idea is that whenever you would have only one line, you can skip these brackets. Okay, that is okay. But if you have more than one lines, you have to put these brackets in to ensure that the compiler considers all the all the lines of the block as of the if block. Okay, so right now we just have one line, so obviously it is understood for the compiler whatever the line is after the if statement, it is going to be the part of the if block, so we don't need to write here the brackets. Similar cases with the else block. When you have multiple lines in the else and if block, you need to make sure that you enclose all of those lines in these brackets. Okay, so that is basically a simple if else statement. Hope you have got the point. So if basically here you can have any condition. So let's say I could be general. So let's say I say a is greater than 10. So right now you can see that a is not greater than 10, it is rather 9. So what's going to happen, that this condition is going to be false, so it's going to print out this else statement. So let's go ahead and try it. So we'll just go here, run our program again, no errors, we run the binary file, and you can see that it says a false. So if we reverse this thing, if I say a is less than 10, now it is true because a is equal to 9. So this time it's going to print out this true. So if I save it, I go back, I try to run my script, and if I try to run the binary file, you can see that it says true, right? So that is it. Hope you got the point. So now let's talk about if else if statement. So an if statement can be followed by an optional else if and else statement. So which is very useful to test various conditions using single if else if statements. When using if else statements, there are a few points that you need to keep in your mind. So an if can have 0 or 1 else's, and it must come after any else ifs. The second thing is an if can have 0 to many else ifs, and they must come up before the else. So you would understand it better when I would basically write the code here. Okay, so let's say that we have integer, we have a is less than 10, or let's say that we want to write here, let's say we write here a double equals 10, and then we can write here else if. Okay, so in that thing you can also have a condition. So let's say that I write here a double equals 20, right? So in that case it's gonna check, and if a double equals 20, what I can do is that I can write here true. So here what I was talking about you would understand now. So if a is equal to 10 and it is, let's say it is not equal to 10, so it would leave this condition, it would come here and it would check this, if a is equal to 20. If that is not true, it would go ahead, right? Hope you have got the point. So now what we would do, we can write here another else if statement. We can write as many else if statements as we like or want. Okay, so there is no issue with that. So let's say I write here a equals to 30, so right now I come here, I see out here, let's say true as well. So in these three cases it's gonna print out true, and in any other case it's gonna print out false, right? And let's say if this statement becomes true, it would leave every else if statement. All right, let's say if this statement comes true, it would skip, it would not go towards other else if statements. It would just print it out and finish the code. Bingo, that's it. That simple is that. So in the end, I can also have an else block, let's say, and in here I print out, let's say, false. Okay, so simple is that. I write here end L. So now we are all done. So what would happen, that let's say we have here a is equal to 9. Okay, so what would happen, that the compiler would come here, it would check if a is equal to 10, no, it is 9, so it would leave that, right? It would come here, if a is equal to 20, it would check again, and it is not 20, right? It is 9. So it is false, obviously, so it would not execute that block as well. So it would come now here, and it checks again, it is 9, it is not 30, it skips it, it comes here and it executes this else block, okay, without checking, okay, because all the checks have been, gone. So now if we save it, we go back to our terminal and we try to run our program. And if we run binary file, you can see that it prints out false. Why? Because a is not 30, it's not 20, it's not 10, it's 9. So what I can do is that I can write here, let's say 20. So now it's gonna come here. It's not 10, obviously, so it would skip this. It would come here. So what I can do is that I can specify here true 10, let's say, so that you understand better that which true it is, right? So I can write here true 20, and similarly I can write here true 30. Okay, so right now you can see that it would come here and it would not execute this one. It would come here, it would execute this one. It is true, right? It matches. So it would basically print this out and the program ends. It is not going to go ahead and check the other else if, right? So if we save it, if we go back right here, we try to run our program. Let me just clear it. We write here, we run here the binary file, and you can see that it says true 20. Okay, so that's how if else and else if statements work. Hope you've got the point. All right, so now let's discuss for loop. A for loop is a repetition control structure that allows you to efficiently write a loop that needs to execute a specific number of times. So the general syntax of the for loop would be something like that. So let me just get rid of all that code so that I can show you. So the general structure of the for loop is going to be something like this. So you would have for loop here. You would have an integer and a variable, let's call it I. Then you would have here the condition, and then you would have here the increment statement. And after that, you would have a body of the for loop, and whatever you would write inside the body of the for loop, that would be executed that many times, how many times the condition would be satisfied. Obviously, the structure of that for loop would be, first, it would be something like this. We'd have here a variable, let's call it integer I. All right, let's put here a condition that integer I is less than 10. So it means that until and unless I does not become 10, it would not break the for loop, all right? Which means that it would print out the value still 9, right? So on 10, it would break the loop because 10 is not less than 10. If we put here an equal sign, in that case, it would basically execute it another time. But now we don't have an equal sign here, so it would not execute it once more, right? So here you gotta have the incremental statement, which would have something like I plus plus. And inside here, you're gonna have the whatever the statement that you would like to have here, okay? So let's say that we wanna have here a statement, C out. And then we would like to have here value of I equals or colon, and then we write here the value of I as A, and then we write here end L. All right, excuse me, we're gonna write here I. So what's gonna happen is that first of all, this loop is gonna come here. It is going to, it's going to check if I is less than 10 or not. Obviously, this is going to be true because 0 is less than 10, right? So it's going to print it out. It's going to go back. It's going to increment it. then the value would become 1. It would check it again, print it out, goes back again, increment it, and then it would basically, the I value would become 3. So let me just print out the results, and then I'll explain to you in detail. So right now we go back to our terminal, we try to run our code. You can see that there are no errors. So now we run the binary file, and you can see that it says the value of I is 0, value of I 1, 2, 3. You can see that this same statement has been executed 10 times. How I say 10 times? Because it starts from 0 and it comes till 9. If we would have the value of I as 1, it would have basically done what? It would have started from 1. So here we have 0, it checks it, this is true, it executes it, then it basically increments it, then it comes back here, the I value becomes 1 more, so it becomes 1, checks again, come here, print it out, increment it, goes back here, it becomes 2, checks it, true, yeah, it is true, and then comes back, execute this statement, increment it, goes back, it becomes 3, 4, so on and so forth, right? Until it becomes 10, it prints out 9 here, let's say, in the final line here. So it prints out 9, it goes back, increment it, now it becomes 10. So it comes here, I is 10 basically, it comes here in the condition, and 10 is not less than 10, so the statement is false. So instead of printing it out, it breaks the loop and it comes here and the program ends. Okay, so that's how simple for loop is. You can have multiple for loops. You can have a for loop inside the for loop. You can have if conditions inside the for loop, but that is a topic for another day.
Our topic is while loop in C++, and we will see that what is while loop and how we can create while loop using C++. So what is while loop? A while loop is a control flow statement that continuously executes a target statement as long as a given condition is true. The syntax of a while loop in C++ is like this. After writing the while keyword, we have the condition inside the bracket. This condition is also called as test expression. And inside this while loop, we have a single statement or multiple statements. The while loop evaluates the test expression. If the test expression is true, codes inside the body of the while loop is executed. Then the test expression is evaluated again. This process goes on until the test expression is false. When the test expression is false, while loop is terminated. Here we can have a single statement or a block of statements. The condition may be any expression and it is true in any non-zero value. This is the flow diagram for the while loop. Loop start executing, it evaluates the test expression. Then it will go to the block B and the loop will keep on running until the condition is true. When the condition becomes false, the while loop terminates. Let's see two examples to understand the while loop in C++. Include the IOStream library first. Define the namespace here using namespace std. Define the main function. And inside this main function we have a variable which is number. So int number is equal to, so you have to assign a value here initially to this number, and I'm gonna assign it 5. So we have to start a while loop here, write the keyword while, and inside these brackets we have to specify the condition. So let me write here number is less than 10. So this while loop will work until the number is less than 10. Right here cout value of number is, and here you have to write the name of the variable, that is number. Number plus plus When this while loop will start executing, it will evaluate the condition. If the value of the number is less than 10, then it will print the value of the number and it will increment the number by 1. This execution of loop will continue until the value of the number is less than 10. Write the return statement here, and let me just save this file. The file is saved here. Open up the terminal. Write here g++ loop.cpp, which is the name of our file. So hit enter. So it has created a new file, that is a.out. So run it, a.out. And here is the output, and you can see that the loop is executed until the value of the number is 9. And the second example is that we can change this condition. So I'm gonna make it 20 instead of 10, and now let's run it. And you can see that this time it has printed the value of the number until it is 19. So that's it for this topic. Our topic is switch statement in C++. So what is a switch statement? A switch statement allows a variable to be tested for equality against a list of values. Each value is called a case, and the variable being switched on is checked for each case. It works more similar to the if-else condition. This is the syntax of switch statement. First of all, we have to write the switch keyword, and then we have to mention the expression. The expression used in a switch statement must have an integral or enumerated type, or it could be a class type. After the switch keyword, we have multiple case statements. You can have any number of case statements within a switch. Each case is followed by the value and a colon. The constant expression for a case must be the same data type as the variable in the switch, and it must be a constant or a literal. When the variable being switched on is equal to a case, the statement following that case will execute until a break statement is reached. When a break statement is reached, the switch terminates and the flow of control jumps to the next line following the switch statement. Note, every case needs to contain a break. If no break appears, the flow of control will pass to the next line until a break is reached. A switch statement can have an optional default case which must appear at the end of the switch. The default case can be used for performing a task when none of the cases is true, so no break is needed in the default case. Now let's understand the switch statement in C++ by a practical example. Create a new C++ file and include the IOStream library. IOStream. Define the namespace here using namespace std. So now you have to declare a main function, that is int main. This example is gonna be about student GPA. The student will enter the grade and the program will tell that what GPA the student has acquired. I am declaring a new variable here, that is char, and the name is grade. The student has to input the grade, so write here cout. Enter the grade. Store the value into the grade variable. And we have to print the grade here, whatever the student enters. So write here cout. Your grade is, and write here the name of the variable, that is grade. We have multiple scenarios for the grade, like the grade could be A grade or B grade, C, D or F. That's why we need to create a switch statement here. So write the keyword here switch, and inside these brackets we have to write the name of the variable that we have to test it for the equality, and that is grade. So we have multiple cases for the grade here. The student can enter grade A, grade B, grade C, grade D, and grade F. So the first case is gonna be case A. If the student enters the grade A, then we have to print here C out. You have 4 GPA. Now write here the break statement, because we have to terminate the flow of the program. If the student enters grade A, then the program should print you have 4 GPA and the flow should be terminated. And the second case is grade B. And for grade B we have to write here C out. You have 3.7 GPA. And similarly we have to put break statement here as well. And the case number 3 is grade C. So we have to print here you have 2.5 GPA. And the fourth case is grade D. Print here you have 2 GPA. And the final case is grade F. For the final case, define the case here F. And if the student enters grade F, then you have to print here better try again and insert the break statement here. So we have covered all the possible cases that could be in the case of grade. So now we have to put the default case here. If the student enters any value other than A, B, C, D, F, so it will be handled in the default case and the system will print invalid grade. So we do not need to put the break statement in the default case. Here write return 0. Now save this file, open up the terminal and execute this file, that is switch.cpp. So write here g++ switch.cpp. So it has created a new file here, that is a.out. So let's execute it. a.out. Enter the grade. Let me enter the grade A here. And your grade is A and you have 4 GPA. And let's run it again. And now enter the grade here B. Let me open the code. And now enter the grade B. And you can see here you have 3.7 GPA. So what exactly it has printed here on the terminal. And if we run it again, enter a wrong grade. Let me just enter Y here. So in this case, it has executed the default case and it has printed here that is invalid grade. So that is how you can use switch statement in C++. Our topic is arrays in C++. So let's see that what is an array and how we can create and deal with arrays in C++ language. An array is a data structure in C++ It stores a fixed size sequential collection of elements of the same type. An array is used to store a collection of data, but it is often more useful to think of an array as a collection of variables of the same type. Instead of declaring individual variables such as number 0, number 1 and number 99, you can declare one array variable such as numbers, and you can use it to store the numbers. A specific element in an array is accessed by an index. To declare an array in C++, we have to specify the type of the element. Like if we want to declare an integer array, so write here int, and here you have to write the name of the array. Let's create an array of numbers, so write here numbers. After this, we have to specify the number of elements required by an array. So if you want to declare an array of 10 numbers, so you have to write here 10, and if you want to declare an array of 100 numbers, then you have to write here 100. So let me just create an array of 10 numbers for this demonstration. You can initialize C++ array elements either one by one or using a single statement. Like if we want to initialize this array with 10 numbers, so we can do this in this way. You have to start these brackets, and inside this bracket you have to write the numbers, and the numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. The number of values between braces cannot be larger than the number of elements that we declare for the array. So for example, I have declared here 10 numbers, and if I write here 11 numbers, so definitely it will be an error. So we have to take care of this thing in order to prevent the errors in the program. So what we can do with these numbers? So in order to print these numbers, we have to start a for loop for int I is equal to 0, I is less than 10. I have started the for loop with I is equal to 0 because the index of the array starts with 0. So if we have like an array of 10 numbers, it means that its index starts with 0 and it will go up to 9. So I is less than 10 and I plus plus. So this for loop will run 10 times. To print the numbers of the array, write here cout. The number is and write here the name of the array, that is numbers, and we have to specify the index here. So when the value of the I will be 0, it will print the first number, that is 1. And if the value of the I is 1, so it will print the second number, that is 2. Add the return statement here, return 0, and save this file. The file is saved on desktop, so we have to open up the terminal in order to execute this file. So open the terminal and write here G++, and the name of the file is demo.cpp. So it has created a new file, that is a.out. So let's execute this file, a.out. And you can see that it has printed the value here, that is 1, 2, 3 and up to 10. And similarly we can increase the size of this array. So let me just make it 15 numbers array and add the numbers here as well, 13, 14, 14 and 15. We also have to increase the size of the for loop. So here you have to specify 15. Open up the terminal again, write here G++ demo.cpp. The file is compiled, so run it, a.out. And you can see that it has printed the numbers 15 times now. So that's how we can create the array in the C++, and we can print the values of the array by using for loop. So that was the simple example of an array. there is a case that if we do not initialize the array, so how we can input the numbers into the array? That is very simple. So let's see how it works actually. Here I have another variable that is integer type, and the name of the variable is sum, that is equal to 0. Now we have to insert the items or values into the array. So we have already declared the for loop. If I say that sum is equal to sum plus 10, okay, so the initial value of sum is 0. So when this for loop will execute for the first time, it will add up the 10 in the sum variable. So the value of the sum variable will become 10, and when for loop will run for the second time, the value become 20, because it will add 10 into the sum variable every time the for loop will execute. So now let's run it, and now we have to store this sum value at each index of the numbers array. We have to store this sum value at each index of the we have to store this sum value on each index of the array. So in order to do this, write here the name of the array, that is numbers. Write here the index, that is I. It is equal to sum. The value of the sum variable will be assigned to the array. So if I say the for loop execute for the first time, the value of the sum variable is 10. So at the index 0 of the array, we will have value 10, and similarly it will increase by 10. So let me save this file, go back to the terminal, compile this file, and run this. And you can see the output. At the index 0 we have the value 10, and similarly for the second we have value 20, and it goes up to like 150. If you increase the size of the array and increase the size of the for loop as well, and run this program again, and you can see that this time it has printed the value till 200. We can also add up all the numbers that are stored in the array. So for this we have to initialize another for loop. For int j is equal to 0, j is less than 20, and j plus plus. Declare another variable here, that is int array underscore sum, because we have to store the sum of all the numbers of an array into this variable. Write here array underscore sum, that is equal to array underscore sum plus numbers into j. So when this for loop will run, it will get the value that is stored on the index 0, and similarly this for loop will run for the 20 times, and it will add up the value in the array underscore sum variable. So at the end of this for loop, print here the sum is, write here the name of the variable, that is array underscore sum. Go back to the terminal, compile this file, and execute it. It has printed here the sum, that is 2100. So that is how you can create and manipulate the arrays in C++. So that's it for this topic. Our topic is date and time in C++. The C++ standard library does not provide a proper data type for time and date. C++ inherits the structure and functions for date and time from C. To access date and time related functions and structures, you would need to include ctime header file in your C++ program. Following are the important functions which we need while working with date and time in C++. So let's see a practical example of C++ program, that how we can get the current date and time by using the C++. This is the demo.cpp file. First of all, we have to include iostream and ctime library. Hash include iostream and now include the ctime library. Define the namespace here. Define the main function now. We have to get the current date and time of the system, so let me just comment this thing. Current date and time. We have to use the time underscore t function here, so write here time underscore t. Now define the new time variable, that whatever you want, and I'm gonna write here time now, which is equal to time 0. So this is the syntax that how we can get the current date and time of the system. The time and date that we will get will not be in the string format, so we have to convert this time and date into a string format. So write here char static and define the variable like dt, which is equal to c time, and here you have to write the name of your variable, your time variable, and that is time now in our case. So just write here after the AND operator. Now we have converted the date and time into the string format, and now we have to print it. So write here cout the current date and time is. Now we have to write the name of char variable, that is dt, and end the line here. Now go to the desktop, open up the terminal, write here g++, and now write the name of the file, that is demo.cpp. It has created a new file, that is a.out, so we have to execute this file. So you can see that it has printed the current date and time. If you want to retrieve the current system date and time in coordinated universal time, that is UTC, so you can do this in this way. Write here tm gmtm, that is equal to gm time, and here you have to write the name of your time variable, that is time now. Write here dt, that is equal to asc time into gmtm. Now we have to print this dt variable, so write here cout the UTC date and time is. Write here the variable dt and end the line. Minimize this program and compile this demo.cpp file again, and run this a.out file, and you can see that it has printed the local time as well as UTC date and time. So that is how you can use date and time in C++. Our topic is basic input output in C++. The C++ standard libraries provide various set of input output capabilities. C++ input output work in streams, which are sequence of bytes. If bytes flow from a device like a keyboard, a disk drive, or a network connection to the main memory, then it is called input operation. And if bytes flow from main memory to a device like display screen, a printer, a disk drive, or a network connection, then it is called output operation. So these are the IO library header files in C++. So the first one is iostream. This file defines the cin, cout, cerr, and clog objects, which correspond to the standard input stream and the standard output stream. And the second library header file is iomanip. This file declares services useful for performing formatted IO operations. And the third is fstream. This file declares services for user-controlled file processing. So let's see a couple of examples of input-output functionality, that how we can implement this in C++. This is my demo.cpp file, and the first example is gonna be about cout, which is standard output stream. So first of all, include the IOStream library here. IOStream. Define the namespace using namespace std. So define the main function here, that is int main. Declare an integer variable here, that is number, and assign the value 10 to this variable. If you want to print the value of this variable, so write here cout. The cout object is said to be connected to the standard output device, which usually is the display screen. The cout is used in conjunction with the stream insertion operator, which is written as like this. So now write here the value of the variable is, so now you have to write the name of the variable, that is essentially num, and after this end the line here. The demo.cpp file is saved on my desktop, so open up the terminal here. Write here g++ and the name of the file, that is essentially demo.cpp. Alright, the file is compiled, so run the file a.out, and you can see that it has printed here the value of the variable is 10. So that is how we can use the cout to print any output to the display screen. The next example is standard input stream, which is essentially cin. So let me just remove this code because we do not need this anymore. Let me declare an array of the name here, that is char name, and it has the limit for the 50 characters, and print it out here for the user that enter your name, and the line here. Now write here cin and write the name of the variable, that is name. So whatever the user will enter in response of this output that enter your name, so it will be stored in this variable, that is name. And similarly we can ask user to input the age. So let me declare a new variable here, that is int age. Print out here, enter your age. So store the age value in the age variable cin and age variable. So whatever the name user will enter will be stored in the name variable, and similarly the age will be stored in the age variable. So in order to print the name and the age that is entered by the user, write here cout. The name is name and the line, and similarly the age is write the name of the variable, that is age, and the line here. Go back to your terminal and compile this file again. Write here g++ and the name of the file demo.cpp. Hit enter. The file is compiled. Now execute the a.out file. So enter the name. So let me just enter Mark here, and the age is 22. So it has printed the name here, that is Mark, and the age is 22. So that is how you can use the cin to store the input of the user into different variables. So that's it for this topic. Our topic is break statement in C++. The break statement has two uses in C++. When the break statement is encountered inside a loop, the loop is immediately terminated and the program control resumes at the next statement following the loop. And the second use is, it can be used to terminate a case in a switch statement. So if you are using nested loops, like one loop inside another loop, the break statement will stop the execution of the innermost loop and start executing the next line of the code after the block. And this is the syntax of break statement in C++. When we have to use the break statement, we just write the break keyword and it works. And this is the flow diagram of the break statement in C++. It starts from the conditional code, and if inside the conditional code you have a break statement, then the flow terminates. And if you don't have the break statement, then the program will keep executing. So now let's try to understand the break statement in C++ by a practical example. So this is my Linux Mint 19.3 Cinnamon, and I have a file here that is demo.cpp, and it has iostream namespace and the main function. Let me just declare a new for loop here. For int I is equal to 0, I is less than 10, and I plus plus. So what this for loop does, it actually prints a line. So what this for loop actually does, it actually prints the value of the I. The value of I is I, and ENDL here. I am putting an if condition here. If I is equal to 5, then the loop should be terminated. So for this purpose, I am inserting a break statement here. So when the value of the I will be 5, the loop will terminate, and basically it will print the value of the I for the 5 times. So save this demo.cpp file, go back to your desktop and open the terminal, and write here G++ and the name of the file, that is essentially demo.cpp. And the file is compiled. Now run the file a.out, and you can see that it has printed the value till 5, because when it reaches to the I is equal to 5 condition, it finds the break statement here and the flow terminates. So that is how you can use the break statement to terminate the flow inside a loop. So this is our previous example of the switch statement, which we have discussed in the switch part. So here we have multiple break statements, and if a particular case reaches, so at the end we have a break statement to terminate the flow of the system. So the student will enter the grade, and if the value of the grade is A, it means it is the first case, that is a case A, and it will print that you have a 4 GPA, and after printing this line it will execute the break statement, and this break statement will terminate the flow of this program. And similarly, if the student enters the grade B, then it will print that your GPA is 3.7, and then it will execute the break statement and the flow will get terminated. And similarly for the C, D, and F, we also have the break statement inside this case. And for the default value of the case, we do not have any break statement, because this is the last line to execute and the flow terminates automatically. So that is why we do not have the break statement inside the default case. So let me just minimize this file and write here G++, and the name of the file is switch.cpp. The file is compiled. Now run the a.out file and enter the grade here, that is A. So when it reaches to this case, that is case A, it has printed a line that you have a grade 4 GPA, and after printing this line it executed the break statement, so therefore the flow terminated. So that is how the break statement works to terminate the loop and the switch statement. So that's it for this topic. Our topic is continue statement in C++. The continue statement works like the break statement, but instead of forcing termination of the for loop or the program, it continue forces the next iteration of the loop to take place, and it skip any code in between. For the for loop, continue causes the conditional test and increment portions of the loop to execute. For the while and the do while loop, program control passes to the conditional test. The syntax of continue statement in C++ is very simple. So wherever you want to add the continue statement, you just have to write the continue keyword. This is the flow diagram of the continue statement. It starts with the conditional code, and when it finds the continue statement, it skips that portion of the program and it executes the next condition or the next iteration. So in this way it is quite different to the break statement, because when we enter the break statement and the program finds the break statement, it terminates the program. But on the other hand, in continue statement, it skips that piece of code and it executes the next iteration. So now let's see through an example of C++ that how continue statement works. This is my demo.cpp file. I have included the IOStream library and I have defined the namespace and the main function. So in order to check the functionality of the continue statement, I have to start a for loop here. For int I is equal to 0, I is less than 10 and I plus plus. And let me print the value of the I here. The value of I is I. So I put an if condition here. If I is equal to 5, then the value of I should not be printed. It should be skipped and the next iteration should be run. And let me put this thing into the else block. So when this condition will be true, if I is equal to 5, it will not print the value of the I. It will skip this line and it will move to the next iteration. So minimize this file, go back to your desktop and open the terminal. G++ and the name of the file, that is demo.cpp. The file is compiled. Now execute the a.out file. And you can see that it has not printed the value of the I when the value of the I is equal to 5. So basically it has skipped this. So let's go back to our code and try to understand this. So when I is equal to 5, the continue statement execute and it skipped that line. So it execute the next iteration, that is I is equal to 6. So therefore we do not have a line here that the value of I is equal to 5 because this line is skipped. So I hope you have got the point. So this is how the continue statement works. Our topic is pointers in C++. In C++, pointers are very easy to learn. So in C++, many tasks are performed using the pointers like dynamic memory allocation, and we cannot do it without pointers. So let's see through a couple of examples that how we can make pointers and use pointers in C++. As we know that every variable is a memory location and every memory location has its address which can be accessed in C++ using the AND operator. So for example, we have two variables, int variable 1 and int variable 2, which is an array of 20 numbers. If I want to print the address of these variables, so I will write here the address of variable 1 is so when we have to print the address or we have to access the address, we have to write and here, and then we have to write the name of the variable, that is variable 1, and the line here. And similarly for the second variable, the address of variable 2 is and the name of the variable, that is essentially variable 2. Alright. Add return statement, return 0. So open up the terminal. Write here G++ and the name of the file, that is essentially demo.cpp. The file is compiled. Now run the a.out file and you can see that it has printed the address of both variables. So a pointer is a variable whose value is the address of another variable. Like any variable or constant, you must declare a pointer before you can work with it. So to declare a pointer in C++, you have to mention the type of the pointer here. Then you have to put the static and then you have to write the name of the pointer, and I have written the name of the pointer IP. Let me just remove these lines because we do not need it anymore, and we also do not need this variable 2, and the value of the variable is 30. Now assign the address of the variable 1 to the pointer variable. Write here IP and the name of the variable, that is variable 1. So the address of the variable 1 is stored in IP variable and the value of the variable 1 is assigned to the static IP variable. So right here cout the value of the variable is variable 1, and now we have to print the address that is stored in the IP variable. So right here cout the address stored in IP variable is right here IP, and similarly we can print the value that is stored in the static IP variable. So for this, let me just copy this line and paste it here, and the value of the static IP variable is, so put the static here and you will get the value that is stored in the static IP variable. So open up your terminal, compile this file again, and now run this file, and you can see that the value of the variable is 30 and the address stored in IP variable is this, and the value of the static IP variable, which is the pointer, is 30. So this is how you can use the pointers in C++ to access the address of the other variable and the value of the other variable. So that's it for this topic. Our topic is file read and write in C++. So far we have been using the IOStream standard library, which provides cin and cout methods for reading from standard input and writing to the standard output respectively. So in this topic I will show you how to read and write from a file, and this requires another standard C++ library which is called fsteam. So let me just include this library here. Include fsteam. So first of all we have to write the data into a file. While doing C++ programming, you write information to a file from your program using the stream insertion operator, and you use that operator to output information to the screen. The only difference is that you use an offstream or fsteam object instead of the cout object. And after writing the data, you have to read it from the file, and you read information from a file into your program using the stream extraction operator, as we use that operator to input information from the keyboard. So the only difference is that we use an ifstream or fstream object instead of the cin object. So I assume a student example here, and we will enter the student name and the student age from the terminal, and we will store this information into the file, and then we will read this information from the file. So here let's declare a student array, which is the 100 characters array. So first of all we have to write the data into the file, so we have to open the file first, and to open the file we need offstream object. So write here offstream and define the object here. So in my case I am writing here output file. Now we have to open this output file here. So call the function open, and inside these brackets we have to write the name of the file that we want to create. So the file we want to create is the student file, and this file will be the binary file, so the extension will be dat. So ask user or student to enter the name here, that what we have to store into the file. So write here cout, enter the name, write here cin, and call the function .getLine, because the name could be the multiple words name. And write here the name of the array, that is the student array, and the size of the array, that is 100. So now we have to store the student name into the file, that is output file. So write here output file, and write here the name of the array, that is the student array. And similarly we can take the student age here. So write here cout enter your age. So the age will be a number, so we do not need the getLine function here. So simply to store it into the array, write here cin and the name of the array, that is student array, and call the ignore function here. The ignore function is used to skip the characters in the input stream. And now write this age value into the output file, name of the array, that is the student. So that is how you can write the data into the file. So after writing the age value into the file, we have to close this file. So that is how you can write the data into the file. So now we have to read the data from the file. So let me comment a line here, reading the data from file. So to read the data from the file, we need if stream object. So write here if stream and define the object, that is the read file, or it could be any name. So instead of the read file, you can write any name, whatever you want. And now we have to open the file, read file.open, and the data is stored into the student.dat file. So we have to open this file. So first of all, we will read the name of the student from the file. So I will write here the name of the student is and write here read file and write here the name of the array, that is the student array. So to print the name on the screen, write here cout student and close this file. Add the return statement and open up the terminal and change the directory to the desktop because the file is saved on the desktop. So write here g++ and the name of the file, that is demo.cpp. So the file is compiled. Now run a.out file, enter the name, that is Mark, and the age is 21. So the name of the student is Mark. So first of all, here it is writing the data into the file, and here it is reading the data from the file. And similarly, if you want to print the age of the student here, so again write here read file student, and now to print it on the screen, write here cout the age of the student is, and write here cout student. So if I go back to my terminal again, and if I compile this file, and if I execute it again, write the name Kamran, and the age is 23. So the name of the student is Kamran and the age is 23. So that is how you can write the data into the binary file and you can read this data. So that's it for this topic. Our topic is functions in C++. A function is a group of statements that together perform a task. Every C++ program has at least one function, which is called main function, and all the most trivial programs can define additional functions. So you can divide up your code into separate functions. How you divide up your code among different functions is up to you, but logically the division usually is such that each function performs a specific task. So that is how you can declare a function in C++. So when you declare a function, you have to mention a return type, you have to mention the function name, and then you have to define the parameter list, and after this you have to define the body of the function, that what should the function do. So basically the body defines all the logical things that a function actually do. So a function consists of following parts. So the first part is the return type. A function may return a value the return type is the data type of the value the function returns. Some functions perform the desired operations without returning a value. In this case, the return type is the keyword that is void. And if a function returns an integer type of value, then the return type of the function is integer. And if it returns a string type, then the return type of the function is string. And if it does not return anything, then the return type is void. So after the return type, we have the function name. So this is the actual name of the function. The function name and the parameter list together constitute the function signature. And after the name, we have parameters. A parameter is like a placeholder. When a function is invoked, you pass a value to the parameter. This value is referred to as actual parameter or as an argument. The parameter list refers to the type, order, and the number of the parameters of a function. Parameters are optional. That is, a function may contain no parameters or a function contain multiple parameters. So the parameter thing is the optional in a function. So after the parameter, we have the function body. The function body contains a collection of statements that define what the function do. So now let's see through a couple of examples that how we can define functions in C++ and how we can use functions. So this is my Linux Mint 19.3 and here I have a demo.cpp file. This demo.cpp file includes the IOStream library. It has a namespace and a main function. So when we define a function in C++, it basically promotes the reusability of the code. For example, you have to sum two variables, and if you have to do this task for the multiple times, so there is no need to write this code again and again in the program. So if you define a function for the first time in your C++ code, so you can call this function and you can perform this task. Like whenever you have to sum two variables, you do not have to write the code again and again. So you can call a function, you pass the value of the variables as a parameter in the function, and that's it. So let's consider a scenario where we have to sum two variables. So let me just define a function here that is int sum, and it has two variables as a parameter. The first is the variable a and the second variable is integer b. So when you have to define multiple variables into the parameter list, then you have to separate them through a comma. So the return type of the function is integer and the name is sum and the list of parameter is integer a and the integer b. And the return type is integer because it will return an integer value after calculating the sum of two variables. So inside this sum function, I have a local variable which is int result, and this is a local variable and its scope is limited to this function, and the result variable is equal to a plus b. So basically this result variable contains the sum of two variables a and b. Okay, so at the end we have to return this result variable. So this is now my main function and I have to call this sum function inside this main function to perform the task or to calculate the sum of two variables. So here I have two variables that are int a is equal to 10 and int b is equal to 20. So I have to calculate the sum of these two variables. I will declare a new variable here, that is the int result variable. So in order to perform the addition or sum of these two variables, I will call the sum function here, and I will pass these two variables a and b as an argument or as an parameter, a and b. So this sum function will return a value which will be stored in this result variable. So it is not necessary to create a variable in the main function with the same name as the parameter in the calling function. So if I have int a here and if I have int b here, it doesn't mean that I have to define int a and b here. It could be any variable, like it could be variable 1 or it could be variable 2, and then I have to pass here variable 1 and variable 2, and this result variable can also be different. So in order to print the sum, right here the sum is and the sum is stored into the result variable. So write here result. So in the main function we have this result variable, and it will never ever call this result variable because the scope of this variable is limited to the sum function. So it is obvious that when we write result here, it will call this result variable. So open up your terminal, and demo.cpp file is stored on desktop. So change the directory to the desktop. Write here G++ and the name of the file, that is essentially demo.cpp, and now compile this. The file is compiled. Now execute a.out, and you can see that the sum is 30 because 10 plus 20 is equal to 30. And if I change the value of the variable 1 here, let's make it 50 and compile this file again and execute it again. So this is how you can declare the functions in C++ and you can use them. And similarly you can sum up 3 variables here, and I have to define here a plus b plus c. So while in the main function we have to declare another variable, that is variable 3, and define the value here for the third variable, for example that is 30, and I have to pass this variable here and run this program again, and the sum is 100 because 50 plus 20 plus 30 is equal to 100. So now define another function here which basically point out the maximum number between two variables and return the maximum number. The return type of the function will be integer, or it could be float or string or anything, and the name of the function is max. It takes two variables as a parameter, like int number 1 and int number 2, and this is the body of the function, and here I have to define multiple statements to find out the maximum number. So I will put the if condition here. If number 1 is greater than number 2, but first we have to declare a new variable here. That is the int max number variable. So if number 1 is greater than number 2, then max number is equal to number 1. Alright, else the max number is equal to number 2. Because we have two variables here, so therefore we need only one if and one else condition. So if we have more than two variables here, like 3, 4 or 5, so then we will have multiple if conditions here. So this program is basically very simple to understand, and at the end we have to return this max number. Alright, so you can either put the bracket inside this max number, or you can simply return it in this way. So now in the main function I have int number 1 variable here whose value is 20, and the second variable is int number 2 whose value is 30, and I also have another variable here that is max number, and the max number is equal to max, and here I have to pass two variables that are number 1 and number 2. So to print out the max number, right here the maximum number is max number and at the end put here return 0. Now open up your terminal again and compile this file again. Execute a.out. So the max number is 30. So if I change the value of the number 1 here and I make it 200 and I compile this file again and execute it again, so you can see that now the max number is 200. This is how we can define the functions in C++, and we can use the functions in C++. So that's it for this topic. Our topic is basic math functions in C++. C++ allows to perform mathematical functions. These functions are available in standard C++ and C to support various mathematical calculations, and these functions are included in Math or C Math library. Instead of focusing on implementation, these functions can be directly used to simplify code and programs. C++ provides large set of mathematical functions which are following. In C++ we have multiple trigonometry functions, like we can compute the sine value, the cos value, and the tangent value as well. And similarly we have hyperbolic functions in C++, and we have a function to compute power, to compute square root, to compute log, and many more. Now let's see that how we can use these functions in C++ to perform mathematical calculations. This is my demo.cpp file, and first of all we have to include the math library #include math.h. So first we will discuss the trigonometry functions like sine, cos, and tangent functions. So let me just declare a double variable, double x is equal to, and assign any value like 19.3. Okay. First we will compute the sine value. So let me just write here sine value computation. All right. So to compute the sine value, we have to use the sine function. The sine function is used to calculate the sine of the angle given as an argument in the degrees. So right here, the sine value of x is. So to compute the sine value, we have to call the sine function like this. So right here sine. So now pass the value as an argument to the function, right here x. And similarly we can compute the cos and the tangent value as well. Let me just copy this thing. To compute the cos value, we have to write here cos function. To compute the tan value, we have to use here the tan function. So write here tan. And we also have to pass the value as an argument to the cos and tan function as well. And change the name of the function here as well. And add the return statement at the end, return 0. Now save this file, open up your terminal. The demo.cpp file is saved on the desktop, so we have to change the directory first of all to the desktop. Write here g++ and the name of the file, that is essentially demo.cpp, and hit enter. So the file is compiled. Now we have to execute the a.out file, and you can see that it has printed the values here. The sine value of x is 0.43, the cos value of x is 0.90, and the tan value of x is 0.48. And similarly we can compute the arc sine, arc cos, and arc tangent value. So to compute these values, right here a sine value, and simply we have to update the name of the function here. So to compute the a sine value, we have to write here a sine, and similarly we can compute the a cos and a tan value. So write here a cos, and write here the name of the function a cos, and similarly update the name of the function here, that is a tan. Alright, so if I go back to my terminal, I compile this file again and execute the a file again. So you can see that it has printed the values here. So it is printing NaN for here for the a sign and a cos value. So if I define a new variable here, that is double y, and the value is 0.3. And if I write here in the arcSine functions the value of y and save this file, compile this file again and execute a.out file. So now you can see that it has computed the arcSine and arccos value as well, which is 0.30 and 1.26 respectively. And we can also compute the hyperbolic sine, hyperbolic cos, and hyperbolic tangent value. So I'm gonna write the code for the hyperbolic functions in the fast forward mode, and then I will explain it line by line. Alright, to compute the hyperbolic sine value, we just have to update the name of the function here, like sine h, and then we have to pass the value as an argument to this function. And similarly, to compute the hyperbolic cos or cosine function, we have to write here cos h, and similarly for the tan function, we have to write here tan h. If I save this file and go back to my terminal and compile the file again, and now execute the a.out file, so you can see that it is now printing the hyperbolic function's value as well. So that is how you can use the trigonometry functions in C++. So let me just remove these lines because we do not need it anymore. Now we will discuss the power function. The power function is used to calculate the power of the base raised to the power of exponent. It accepts two double values as arguments, which are the base and exponent's numbers, and it returns a single double integer which is base to the power of exponent. We can easily use the power function in C++. Let me just print here. Return value is. So now you have to write here the name of the function, that is POW. So here inside these brackets, first of all you have to write the base, like I write here 2, and now you have to write here the exponent. Alright, let me just clear the terminal, compile this file again, execute a.out file, and you can see that the power function return value is 8 because 2 raised to power 3 is equal to 8. And similarly we can define the base and the power here separately, like I write here int base is equal to 2 and int power is equal to 3. So if I update the value of the variables here, base, and write here power, so I go back to my terminal again, compile this file, execute a.out file, and you can see that we have the similar results. To compute the square root of any number, we can easily use the sqrt function. Let me just paste this line here to use the sqrt function. The square root of 8 is, so to compute the square root I have to write here sqrt, and I have to pass the value or the number here, that is 8, or it could be any number. So if I go back to my terminal again and compile this file, now run this file, a.out, so we can see that the square root of 8 is 2.82. And we can also compute the log of any value. So to compute the log of any value, you have to write here the function log, and also update the name of the function here, the log of 8 is, so the log function is used to find the natural log of the given number. This function accepts a single double integer value and it returns an integer result of log. There are two other important functions in the math library that are the floor and the ceil function. The floor function is used to return the floor value of the given double integer. It basically rounded down the value. The function accepts a double value as input and returns double integer value calculated using floor. So to print the floor value, right here the floor of value is the floor call here the floor function and pass any double value, like let me just write here 8.98. And similarly we have another function here, that is the ceil function. The ceil function is used to return the ceil value of the given double integer. The function accepts a double value as input and return double integer value calculated using ceil. So to compute the ceil, right here the ceil value is, and here you have to write the ceil function and write here any double value 8.3 and save this file. Go back to your terminal, compile this demo.cpp file again and execute a.out file, and you can see that the power function return value is 8, the square root of 8 is 2.82, the log of 8 is 2.07, and the floor value is 8 because it prints the down value, and similarly the ceil value is 9. So that is how you can use the basic math functions in C++. So that's it for this topic.